Okay, welcome back, C++ students. This is the second half of the loops chapter. We want to talk about some different ways that we can use loops. So, a common one that you're going to see is if I want to keep a total. I briefly mentioned this last time. So here, okay, first time through the loop, sum is 0, num is 1, so 1 is less than or equal to 10, so we go into the loop. So now sum plus equals 1. Okay, just like plus plus, remember plus equals means you add that number. So sum equals 0 plus 1, sum is now 1. And then num is 2, right here. Okay, next time through the loop, 2 is less than or equal to 10, sum is 1, add 2 to it, it's 3, and so forth. You go through. A common way you might do this is to ask users to enter a bunch of values. So instead of 10 cn statements, you make a loop 10 times, and you do a cn and add it to the total. This is a good example of that. How many days do you want to have sales amounts entered? Cool. For day 1, enter the sales. For day 2, enter the sales. And it's going to add all those values up. Just an easy way to do a summation. Okay. Another way you might work, and this is more with a while or a do while, use a special value to say I'm done. You think about typing in Q when you want to quit, for example. What you might do is say, if I can enter a number from 1 to 100 for test score, then I'm going to use a negative number. And assuming they can't get less than the 0, then I would do that. So, one way is to say, okay, I want you to enter, how many values do you want? 5. Okay, cool. Enter your 5 values. Another way would be enter a value or enter negative 999 to quit. You enter a value, enter another value, or enter 999 to quit, and so forth. And this is negative 999 is not great. So here we say we're playing some sports game, and there's no way to get fewer than 0 points. So you type in your number of points for game 1, for game 2, for game 3. And when you enter negative 1 for a game total, what that means is that's not a real value. It's a sentinel, meaning I want to quit. Okay. And there's an example of how that would work. So these are all pretty straightforward. The loop, like the if statement, it's a control structure that comes up a lot, and it's not super complicated. It's more complexity of what you do with it. This is a nice summation of what I kind of talked about. And again, they use the phrases pre-test, post-test. You know what a conditional is. That's the true-false. But pre-test means I test before I enter the loop. And post-test means I test at the end of running the loop, which means it's going to run at least once. And they get some examples here. Let's say I want to have them enter a value. Like I need you to type in a value from 1 to 10. And you type in negative 5. Well, I'm not going to take that value, so I would ask again. For do while, I say enter a bunch of values and type negative 1 when you're done. Cool, that should work. And for loop, which is sort of a special pretest loop, that's pretty much just for if I know exactly how many times I want to count through. They say exact number of iterations, but I say it's a counting loop. Because again, it does 3 things. You set a variable you're going to use to count. You check to see if you're going to do it again, and then you change that variable so that you have an end. Cool. Let's look at something a little more complicated. I hate how this looks without curly braces. So you'd always want to use curly braces. You can kind of see what I mean here. It makes it hard to read. Each time you go into a curly brace, you're going to have a new block, and one of those blocks could be a loop. So you'll see an assignment later on that's like I want to print a square. Okay, well, how would I print a square? Well, in like an ASCII file. Like if I want to use ASCII art, so using just regular characters on the keyboard to make a little picture. I could use asterisks or dots or dashes. So if I want to draw a square, I'd draw a bunch of lines. Let me open up Notepad++ and show you what I mean. Always best to see what I want to do here. So we'll use Notepad, that's fine. I want to draw a box, a 3x3 box. I'll use asterisks. Okay, well, how would I do that? I would do like this, maybe. Well, how would I know how many times to do that? Well, that's pretty easy. First, I've got to make a line that's the right length. And then I just repeat that. That's actually, proof of concept. Just copy and paste it. So to write a program that's going to print these things out, for example, what would you do? Your inner loop is, printing like cout, an asterisk and a space. or maybe just an asterisk if you want it to be a tighter box without spaces. And you do that, until you have a line at the right length. And that loop now goes inside another loop that repeats that whole process however many times. What this is going to do is print a bunch of numbers out, but if you were to change the C out to printing like an asterisk, it'd look pretty much like this. Okay. So here's an example of, now we're getting into a more complicated problem. I want to find all the averages for all my students. Okay, again, break down the problem. Well, I have to first be able to find the average of all grades for one student. Cool. And now I do that for each student. So the inner loop being, I am working with a given student, enter their scores, and we'll finish that loop. And on the outside, now we repeat that process. So when you're making these, I usually would just do one of them at a time. And it's kind of hard to decide whether you should do the outer loop first or the inner loop. But what I might do is maybe write this program, and inside this inner loop here, lines 32 to 36, I might just write C out. This is where the code goes to enter scores for one student, or you know what I mean? I'm just making like a pseudocode of saying, okay, in the inner loop, it's going to ask me to do this. And then maybe in a different program or a different place, I write that program. And then I kind of put it in here. Now, when you do that, you're going to find when you copy and paste, it gets really annoying to get the tabs right. You'll find tab to tab things over and shift tab to tab things backwards will work pretty well. But you'll just kind of find a really common mistake people will make when you start nesting like this is to not have enough not have enough curly braces, because they got to match up. Whenever you go into a text editor like Replilator code blocks, if you select one of these, it's going to show the other one. It's going to select both of them, so you can kind of see that they match. Because if you don't have matching curly braces, what's sort of happening is the compiler gets lost, and so you'll get a bunch of error messages, but they won't really tell you anything useful because it's not really sure what's going on. You kind of find like if you leave off a semicolon, you get the same thing. You get some error messages, and they don't really mean much, but you should go to that error message and say, okay, let's look at the line above it. Is that line wrong? Is it missing like a semicolon, or is it missing, a curly brace, things like that. Okay. So this is kind of the law of squares here. So if I repeat, my 3x3 box that I drew, how many times do I draw an asterisk? 9 times. 3 times 3. For 4, 16. 4 times 4. And again, my inner loop being I'm going to make a line, and my outer loop being I'm going to repeat making a line. And that's why it kind of says the inner loop completes repeating before the outer loop, because you finish printing one line, and then you go back up to the outer loop, and then maybe you go again to make a second line, and so forth. And that's why it says it's the product of total number of repetitions. So if I wanted to make a program that drew like a 3x5 box, how many times is that going to repeat the inner loop? 15 times. All right. This is an optional kind of bonus. I wanted to just mention it while we're here. It's a pretty neat thing. While we're learning to work with loops, like say users typing in data over and over again until they're done, well, there's nothing that says we have to make that the console with text input and text output. It could also be a file, like a file on a flash drive or on your hard drive. It's a little more complicated. There's a few more steps. So I'm just going to give a sort of early preview of it. We're going to do more with this later on. When you do C in or C out, what do? You either read or write. And that's easy because the console is always there while your program's running. If you're using a file, you've got extra steps. You've got to open the file, then you do your reads and writes, and then you close it. And, we're used to using IOStream to input and output to the console. Well, now you use these things. You have fstream. So you have to include the fstream, and there's different types of streams. So, when you think about C in or C out, that's a stream operation. I mentioned that way back when, but we just think of C in and C out working the way they do. But what it's actually doing is you're taking information and putting it like on a hopper, a conveyor belt that prints out on the screen. Or the user can type a bunch of things in, and then the hopper feeds in to the input. Well, it works the same way with a file. So you've got these commands to say, I'm going to open a file. Now, it gets a little tricky to know where the file is going to be, because by default, it's going to put it wherever the .exe is. So you're going to find, like, say you're on your own machine in code blocks, you're looking in like the bin debug folder. So that can get a little complicated. You could also just take the exe, copy it like to your desktop, and put the file there. That would work too. And we'll get into more complex, like, okay, go find a file on my flash drive, or go find a file on a SD card. That's later. But here's how it looks. I open the file, and then it says, okay, with an if statement, if there's no in file, if not in file, then I didn't open the file. It didn't work. So you always want to check when you try to open an input or output that the file actually exists. Things can happen, like a user could bend over and unplug their flash drive, and suddenly that file's not there anymore. But the program's still running, and so you want to check for this type of thing. And then to write to a file, it looks just like cout. So what that's going to do is going to print the words inventory report into the file. And so same thing, you want to use indel probably to make multiple lines. And it works just like cout. So the reason they put this in the loops chapter is because there's a kind of a neat trick. We talked about the program doesn't know when you're done, so you have to type in -1 or something when you do a while loop. Well, it can know when a file is done because the file ends. So it's like this. It's like while input file gets, or reads number. So let's say you got a file that looks like this. Now, of course, this character is not actually in the file. I'll just say it's in the file. There's no last line. If I were to look at a file in binary, it's like the file just ends. So what would happen? I'd go through the loop, and it would succeed reading a 1, then 2, then 5, then 19, then 24. And then when it got here, after 24, this would be false because it wasn't able to read a number. And so it would exit the loop. And then when you're done, you close up. And you always want to clean up, clean up the toy box when you're done. If you have a file open, you should always close it. You don't want to rely on, well, I killed the program that was running, so the file probably closed. It can cause some problems. Among other things, unlike the screen, it might not actually write everything at once. There's a system on computers called buffering, because memory is much faster than a file system. So usually what will happen is it'll write for a while, and it's just keeping that stored in memory. And when you close the file, it may actually finish writing and clean everything up. So just something to keep in mind. Always you have to open your files. Always open your files. Always check to see if there's another line when you're reading, and always close when you're done. Okay. And there's some neat things you can do. Like later we'll look at let them type in a file name. We don't have the file open dialog box like Windows or Mac do, but we can enter the file. And here's an example of that. So this is just going to open the file, and that's it. And then it'll read once it's open. Again, remember nested loop, right? First, I'm nesting here now instead of a bunch of ifs inside of ifs. That you can nest ifs and whiles. So my logic is, okay, try to open a file. If you can't open the file, we're done. Jumps down here. If it can open the file, it goes into the inner loop, and that inner loop is a while loop where it reads all those files. So then it gets everything, closes it up. This part doesn't run because it was true, and then it returns. So here you go. I could have a program like that. I'm going to look at some of these later. So this is just a few more examples of things you can do with these loops. Pretty handy stuff. And we'll carry on next week. All right, thanks a lot.